morning. Myself, Sadishwaran, working as an assistant professor, Department of Medical Electronics, SRM, Pallayamai Engineering College. I am handling MD 3462 Biocontrol System, Unit 4 Stability Analysis. I am going to discuss about problems based on Routh-Hurwitz criterion. Problem number 1 of Routh-Hurwitz criterion. Using Routh criterion, determine the stability of the system represented by the characteristic equation s power 4 plus 8s power 3 plus 18s square plus 16s plus 5 equal to 0. Comment on the location of the roots of the characteristic equation. The characteristic equation s power 4 plus 8s power 3 plus 18s square plus 16s plus 5 equal to 0. In the given problem, the highest power of s is 4, which is a even number. So first row is formed using the even power of s, and the second row can be formed using the odd power of s. So s power 4, so 1, 8, 18, then 16 and 5. So here 1 s power 4, 8 s power 3, then 18 s power 2, 16 s and plus 5. If you observe here, this row is divisible by 8. So 1 8s are 8, 2 8s are 16. Again, the s power 4, it can be rewritten as s power 4, 1, 18, 5, and the second row after divisible by 8, it will become 1 and 2. 1 and 2. We have to compute that s power 2. S power 2 can be computed using 1 into 18 minus 1 into 2 divided by 1. So 18 minus 2, 16, 16 by 1, 16. So s power 2 row, this can be written as 16. Then again here 1 into 5 minus 1 into 0 divided by 1, will be getting 5. Then we have to compute that s power 1 row. 16 into 2 minus 1 into 5 divided by 16. It is 1.6875, approximately 1.7. So s power 1 equal to 1.7. You have to compute s power 0 row. S power 0 row, 1.7 into 5 minus 16 into 0 divided by 1.7, you will be getting this 5. If you observe the first column of Routh array, there is no sign changes is observed. Okay. If there is any no sign changes in the first column of Routh array, which means that this all four roots lies on left half of S plane. So the system is a stable system. Problem number 2. Construct Routh array and determine the stability of the system whose characteristic equation is s power 6 plus 2 s power 5 plus 8 s power 4 plus 12 s power 3 plus 20 s square plus 16 s plus 16 equal to 0. Also determine the number of roots lying on right half of S plane, left half of S plane and on imaginary axis. The characteristic equation of the system: s power 6 plus 2 s power 5 plus 8 s power 4 plus 12 s power 3 plus 20 s square plus 16 s plus 16 equal to 0. The given characteristic polynomial is a sixth order equation and it has 6 roots. Since the highest power of s is even, form the first row of Routh array using the coefficient of even power of s and form the second row using the coefficient of odd power of s. So here this can be written as s power 6 1, s power 5 2, then again 12, 8, 12, 20, 16, 16. If you observe the s power 5 row, it can be divisible by 2. After divisible by 2, this will become 1, 6 and 8. S power 6 and s power 5 row can be written after divided by 2. 1, 8, 20, 16, 1, 6 and 8. You have to compute s power 4 row. Here 1 into 8 minus 1 into 6 divided by 1. 8 minus 6 by 2. 2. Then again 1 into 8, 1 into 20 minus 1 into 8 by 1. 20 minus 8, 12. The last one, 1 into 16 minus 0 by 1, 16. all the row is divisible by 2. After divided by 2, 1, 6 and 8. Again this can be written as 1, 6 and 8. We have to compute the s power 3 row. 1 into 6 minus 1 into 6 by 1. This will become 0. Then again 1 into 8 minus 1 into 8 by 1, 0. When we are getting all the elements of the row is 0, we have to take an auxiliary polynomial A. A is written as s power 4 plus 6s square plus 8 equal to 0. It is divisible by, consider this as A, differentiate A with respect to S, so this will become 4s power 3 plus 12s, 0 is divisible by 4, 1 4s are 4, 3 4s are 12, again it can be written as s power 3 row can be written as 1 and 3. We have to compute s power 2 row, 1 into 6 minus 1 into 3 by 1, value 3. Then again 1 into 8 minus 0 by 1, 8. We have to compute the s power 1 row, 3 into 3 minus 1 into 8 by 3. So 9 minus 8 by 3, 0.33. You have to compute s power 0 row, 8 into 0.33 divided by 0.33, value is 8. If you observe the first column of Routh array, there is no sign changes. We cannot conclude the system is stable here because you are having two zeros. All the rows, all the elements of the rows are 0 in the s power 3 row. So we have to take a auxiliary polynomial. The auxiliary polynomial equal to 0. That is s power 4 plus 6s square plus 8 equal to 0. We have to substitute s square equal to x. This will become x square plus 6x plus 8 equal to 0. Use minus b plus or minus root of b square minus 4ac by 2a. You will be getting the root as minus 2 or 4. Again replace here s square equal to x, then x equal to s square. So s square equal to minus 2, s square equal to minus 4, s equal to plus or minus root of minus 2, plus or minus root of minus 4. This will become j root 2 plus or minus j root 2. Here plus or minus j2. So we will be getting j root 2 minus j root 2 plus j2 and minus j2. So these all the four elements lies on imaginary axis. It does not falls on left half of S plane or right half of S plane. So here these four roots lies on imaginary axis. Totally 6 roots because highest power of S in the given problem is 6. So out of 6, 4 roots lies on imaginary axis. Remaining 2 roots lies on left half of S plane. So the system is limitedly or marginally stable. 4 roots lies on imaginary axis and remaining 2 roots lies on left half of S plane. Construct Routh array and determine the stability of the system represented by the characteristic equation s power 5 plus s power 4 plus 2s power 3 plus 2s square plus 3s plus 5 equal to 0. Comment on the location of the roots of the characteristic equation. The characteristic equation of the system s power 5 plus s power 4 plus 2s power 3 plus 2s square plus 3s plus 5 equal to 0. The given characteristic polynomial is the fifth order equation and it has 5 roots. Since the highest power of the s is an odd number, form the first row of Routh array using the coefficient of odd power and form the second row using the coefficient of even power of s. So here 1, 1, 2, 2, 3 and 5. We have to compute s power 3 row. S power 3 row 1 into 2 minus 1 into 2 by 1, that is 0. 1 into 3 minus 1 into 5 by 1 minus 2. So here s power 3, it is written as 0 minus 2. Replace 0 with epsilon. This will become epsilon into minus 2. The previous row s power 4 is nothing but 1, 2 and 5. So here epsilon into 2 minus 2 into 1 divided by epsilon. Similarly here the next one epsilon into 5 minus 0 into epsilon divided by epsilon. This will become 2 epsilon plus 2 by epsilon and 5. Rewrite here 2 epsilon plus 2 by epsilon and 5. Then again s power 1 row can be formed here. 2 epsilon plus 2 by epsilon into minus 2 minus of epsilon into 5 divided by 2 epsilon plus 2 by epsilon. After simplification, this will become minus of epsilon square plus 4 epsilon plus 4 by 2 epsilon plus 2. Now we have to compute the s power 0th row. So here this element into 5 minus 0 divided with this element, so we will be getting answer 5. The next we have to replace this epsilon with 0 and rewrite the rows s power 5 1 2 3 1 2 5. This epsilon can be written as 0, so 0 and minus 2. Again epsilon 0, if you substitute 0 anything by 0 infinity, so this will become 0 and infinity and 5. Then after substituting epsilon equal to 0, this 0 0 minus 4 by 2 value minus 2 and s naught 5. If you observe the first column of Routh array, there are two sign changes, one between plus infinity to minus 2 and another between minus 2 to 5. That is plus 2 minus 1 change, then next one minus 2 plus. So there are two sign changes in the first column of Routh array, which means that two roots lies on right half of S plane, totally 5 roots. Out of 5 roots, 2 roots lies on right half of S plane, remaining 3 roots lies on left half of S plane. So the system is an unstable system. Even if you observe one sign changes in the first column of Routh array, we can conclude that the system is an unstable system. Since two sign changes are observed in the first column of Routh array, which means that 2 roots lies on right half of S plane and remaining 3 roots lies on left half of S plane, the system is an unstable system. Okay, problem number 4 by Routh stability criterion. Determine the stability of the system represented by the characteristic equation 9s power 5 minus 20s power 4 plus 10s power 3 minus 2 minus s square minus 9s minus 10 equal to 0. Comment on the location of the roots of the characteristic equation. The highest power of in the characteristic equation is 5. So since it has 5 roots, so the first row formed using the odd power of s and second row formed using even power of s. So here 9 minus 20, 10 minus 1 minus 9 and minus 10. We have to compute s power 3. This can be calculated using minus 20 into 10 minus of 9 into minus 1 divided by minus 20, value 9.55. Similarly here the next one, minus 20 into minus 9 minus of 9 into minus 10 divided by minus 20, which is nothing but minus 13.5. So we have to write this s power 3 as 9.55 and minus 13.5. We have to compute s power 2. S power 2 can be computed using 9.55 into minus 1 minus of minus 20 into minus 13.5 divided by 9.55. This is nothing but minus 29.3. We have to write minus 29.3 here. Similarly here 9.55 into minus 10, 0 divided by 9.55, value minus 10. So minus 29.3 minus 10. We have to compute s power 1 row. S power 1 row minus 29.3 into minus 13.5 minus of 9.55 into minus 10 divided by minus 29.3, that is minus 16.8. Similarly, s power 0 can be calculated here. Minus 16.8 into minus 10 minus 0 divided by minus 16.8, value minus 10. If we observe the first column of Routh array, there are three sign changes. One between plus 2 minus first sign change, second minus 2 plus second sign change, then again plus 2 minus third sign change. So if you observe the first column of Routh array, there are three sign changes, which means that 3 roots lies on right half of S plane, totally 5 roots. Out of 5 roots, 3 roots lies on right half of S plane, remaining 2 roots lies on left half of S plane. The given system is an unstable system. So similarly here, by examining the element of first column of Routh array, it is observed that there are three sign changes. So 3 roots are lying on right half of S plane, remaining 2 roots lies on left half of S plane. The system is an unstable system. 3 roots lies on right half of S plane and 2 roots lies on left half of S plane. Problem number 5. The characteristic polynomial of the system is s power 7 plus 9 s power 6 plus 24 s power 5 plus 24 s power 4 plus 24 s power 3 plus 24 s square plus 23s plus 15 equal to 0. Determine the location of the roots on a spin and hence the stability of the system. The given characteristic polynomial is a seventh order equation and so it has 7 roots. Since the highest power of s is an odd number, form the first row of array using coefficient of odd power of s and form the second row using the coefficient of even power of s. Write s power 7 and s power 6 row. That is 1 into s power 7, 9 into s power 6, 24 s power 5, 24 s power 4, 24 s power 3, 24 s square, 23s plus 15. If you look at the s power 6 row, the row is divisible by 3. After divisible by 3, that is 3 3s are 9, 8 3s are 24, 8 3s are 24 and 5 3s are 15. This is s power 7 and s power 6 row is rewritten. So s power 7, s power 6, the x power 6 row after divisible by 3, 3 3s are 9, 8 3s are 24, 8 3s are 24 and 5 3s are 15. You have to compute s power 5 row. To compute s power 5 row, use 3 into 24 minus 1 into 8 divided by 3 value 21.33. Similarly here 3 into 24 minus 1 into 8 divided by 3 value 21.33. Then similarly here 3 into 23 minus 1 into 5 divided by 3 21.33. All the elements of s power 5 divisible by 21.33 value 111. Right here s power 5 is 111. You have to compute s power 4 row. Similarly here 1 into 8 minus 3 into 1 divided by 1 value 5. Similarly here 1 into 8 minus 3 into 1 divided by 1 value 5. 1 into 5 minus 0 by 1 value 5. All the s power 4 element divisible by 5 after divided by 5 values 1, 1 and 1. Right here 1, 1, 1. Now we have to compute s power 3. 1 into 1 minus 1 into 1 divided by 0 value 0. 1 into 1 minus 1 into 1 by 0 value 0. If you are getting all the elements of any row is 0, we have to consider the auxiliary equation a equal to, here a equal to s power 4 plus s square plus 1 equal to 0. Okay, if you differentiate respective 1, 4s power 3, 4s power 3 plus 2s, divide 4 and 2, divide by 2 value 2 and 1. So s power 3 row can be written as 2 and 1. You have to compute s power 2 row. 2 into 0 2 into 1 minus 1 into 1 by 2 value 2 minus 1 by 2 value 0.5. Then again 2 into 1 minus 0 divided by 2 value 1. You have to compute s power 1 row. S power 1 row 0.5 into 1 minus 2 into 1 value minus 1.5 by 0.5 value minus 3. S power 0 can be calculated as minus 3 into 1 minus 0 by minus 3 value 1. If you observe the first column of Routh array, there are two sign changes, one between 0.5 and 3, that is plus 2 minus, and next one minus 2 plus. Since we are observing two sign changes in the first column of Routh array, we cannot conclude only two roots lies on right half of s plane, because all the elements of s power 3 is 0. We have to take the auxiliary equation, that is s power 4 plus s square plus 1 equal to 0. We have to compute the roots. So here s power 4 plus s square plus 1 equal to 0. Replace s square with x. So x square plus x plus 1 equal to 0. Use minus b plus or minus root of b square minus 4ac by 2a. You will be getting minus 1 by 2 plus or minus j root 3 by 2. The given equation is in rectangular form. Convert it into polar form. Use polar form POL open bracket minus 1 by 2 comma root 3 by 2. You will be getting value 1 equal to value 1, then alpha f, if you press you will be getting angle 120. Similarly here first we consider 1 by 2 plus j root 3 by 2, next we have to consider 1 by 2 minus j root 3 by 2. Similarly here polar form of minus 1 by 2 comma minus root 3 by 2 value 1, then you have to find angle alpha f, you will be getting 1 angle minus 120. So, but s square equal to x, s equal to plus or minus root x. You have to put in root x, root x. Root 1, it can be written as root 1. Then angle or root divided by 2 will be getting 60. So you will be getting plus or minus 1 angle 60, and similarly here plus or minus 1 angle minus 60. Again convert it into polar form, rectangular form. Use the rectangular form, open bracket 1 comma 60, you will be getting 0.5. Then use the alpha f, you will be getting j 0.866. Similarly here rectangular form of 1 comma minus 60, and use alpha f, you will be getting plus or minus 0.5 minus j 0.866. So first value plus 0.8 plus j 0.66, then again minus 0.5 plus j 0.866. Similarly here plus 0.5 minus j 0.866, then minus 0.5 minus j 0.866. So out of 7 roots, if you plot here uh, plus, considering 0.5 plus j 0.866 falls on right half of S plane. Similarly here plus 0.5 minus j 866 falls on right half of S plane. If you use minus 0.5 plus j, minus 0.5 plus j getting on left half of S plane. Similarly minus 0.5 minus j falls on left half of S plane. So anyhow, 2 roots lies on right half of S plane. Remaining total out 7 roots, the remaining 5 roots lies on left half of S plane. So the system is an unstable system. Why the system is unstable? Even if you observe one sign change in the first column of Routh array, the system is unstable. But in the problem, we observe 2 sign changes in the first column of Routh array. So 2 root lies on right half of S plane, remaining 5 root lies on left half of S plane. The system is an unstable system. Then the last problem, Routh-Hurwitz criterion. Problem number 6. The characteristic polynomial of the system is s power 7 plus 5 s power 6 plus 9 s power 5 plus 9 s power 4 plus 4 s power 3 plus 20 s square plus 36 s plus 36 equal to 0. Determine the location of the roots on the S plane and hence the stability of the system. Similarly here, the characteristic equation, again rewrite this characteristic equation, and if you observe here s power 7, the highest power is s power 7, so total it has 7 roots. The highest power is s power 7, so form the first row of a Routh array using odd coefficient of odd power of s, and second row formed using even coefficient of even power of s. Now I have to compute that, divide s power 6 row divided by 5 to simplify the computation. Divide by 5, 1 5s are 5, 1.8, and then again 4 5s are 20, 7.2. Okay, so the row can be rewritten as. Now we have to compute s power 5, 1 into 9 minus 1 into 1.8 divided by 1, value 1.8. Then again 1 into 4 minus 1 into 4 by 1, 0. 1 into 36 minus 7.2 divided by 1, value 7.2. Divided by 1.8, we will be getting 104. 104. S power 3, 0, 0. In the previous problem, if you observe that all the elements of any any power of s is 0, we have to consider the auxiliary polynomial as a and differentiate one time. After differentiating, we can write the s power 3 and proceed. But in the problem, we should not do like that, because middle of the value is 0. Okay, so how to proceed? This means first take s power 7 plus s power 6 plus 9 s power 5, 9 s power 4 plus 4 s power 3 plus 20 s square plus 36 s plus 36 divided by that is s power 4 plus 4, and we have to find the coefficient or quotient. So here similarly here s power 7, 5 s power 6, 9 s power 5, 9 s power 4 plus 4 s power 3 plus 20 s square plus 36 s plus 36. Then the characteristic on s power 4 plus 4. We have to compute the coefficient. Okay, in the coefficient can be written as 1599. Similarly here 1599 in s power 3 and s power 2 row, because s power 3 row, all the elements of s power 3 row only 0 in the previous row, in between 0. Because of that we have to write the characteristic equation and divide it by auxiliary polynomial, and we have to find the coefficient. The coefficient comes as 1599 here. So similarly here 1599. Next we have to compute s power 1 row. 5 into 9 minus 1 into 9 by 5, value 7.2. S power 0th row, 7.2 into 9 minus 0 by 7.2, value 9. If we observe, next we have to find the auxiliary polynomial. With that s power 4 plus 4 equal to 0, put s square equal to x. We have to find here x square equal to plus 4, x square equal to minus 4. The value is x equal to plus or minus root of minus 4, which is nothing but plus or minus j root 2. Okay, this plus j root 2 and minus j 2 converted into polar form, this will become 2 angle 90 or 2 angle minus 90. Again put s equal to plus or minus root of x plus or minus 2 root of 90. This can be as root 2 comma angle divided by 2, value 45. Similarly here root 2 angle minus 90 divided by 2, minus 45. Convert this into again rectangular form. So this will become plus or minus 1 plus j1 or plus or minus 1 minus j1. So plus means this falls on right side, minus means falls on left side. So here 4 roots are here, 2 roots lies on right half of the spline, remaining 2 roots lies on left half of left half of S plane. So totally 2 root lies on right half of S plane. Even though there is no sign changes in the first column of root 3, if you are getting all the row elements of the row as 0, so we have to find the roots. The roots can be plotted in a graph. After that 2 root lies on left half of S plane, remaining 5 root lies on left half of S plane. System is an unstable system. So convert like that, and we have to plot. The system is unstable. 2 root lies on right half of S plane and 5 roots lies on left half of S plane. From this we can conclude that the system is an unstable system. In conclusion of the first problem, there is no sign changes in the first column of root 3. The system is a stable system. Coming to the problem number 2, even though if you are not observing any sign changes in the first column of root 30, you are observing the power of s. All the rows, all the elements of the row is 0. We have to find the auxiliary polynomial. You have to find the roots of the auxiliary polynomial, and we are getting 4 imaginary roots. After plotting, all the 4 roots lies on imaginary axis. Even though there is no sign changes and all the 4 roots lies on imaginary axis, it is a limitedly or marginally stable. Then coming to the problem number 3, we are not getting all the elements of the row is 0. We are getting the first element of the row is 0. Replace with some constant, say epsilon, and proceed the problem. And after proceeding the problem, again replace epsilon with 0. And after that, if you are observing any sign changes, that particular root lies on right half of S plane, otherwise the root lies on left half of S plane. Okay, if you are not observing any sign changes in the first column of root 3, and all the auxiliary polynomial roots falls on imaginary axis, it is limited or marginally stable. Okay, but then again, if you are not if you are getting sign changes, okay, considering the 2 sign changes, it means that 2 root lies on right half of S plane, remaining root lies on left half of S plane. The system is an unstable one. You are not observing any sign changes, or if you are getting all the elements of the row is 0, we have to find the auxiliary polynomial roots. And after plotting all the polynomial roots, if you are not getting any sign changes, all the roots lies on left half means stable. If any one of the root lies on right half, it is unstable. Okay, another problem. How many sign changes? For example, three sign changes mean three sign changes. So three root lies on right half, remaining root lies on left half. Then another one problem. Even though if you are getting all the elements of the row is 0, if you look at the previous row, you are having some 1 0 4. If it comes, we have to write the characteristic equation and divide by polynomial, actually polynomial, and proceed that. You are getting some quotient. That quotient can be split into even and odd power of s, and proceed. After proceeding, if you are not observing any sign changes, the system is stable. If you are observing sign changes, the particular root lies on right half, remaining root lies on left half. These are the conclusion about the Routh Hurwitz. All the best. Thank you.